LED technology has been around now for quite some time and has evolved from being a simple identification light to energy-saving solutions for our vehicles, homes, and businesses. But of course, we like to use them in our lightsabers because they are exceptionally bright and they're virtually unbreakable. So the LEDs that I've been using mostly here are the Luxeon Stars or Luxeon Rebel LEDs here. Now these are very thin here with the LED on top, and it is actually quite bright here. So today I'm going to show you how to make a simple heatsink as well as an LED housing for your lightsaber to fit inside of a 1-inch PVC pipe or aluminum tubes. The LED that I'm using for my Darth Maul double-bladed electronic lightsaber project is a Luxeon Star Tri-Rebel LED. So there's actually 3 LEDs here on this one mounting plate. Now I do plan to use all 3 of these LEDs at once because I want to get the maximum amount of brightness here. The only thing is I have to make some solder bridges on some of the power points on here so I can activate all 3 LEDs at once. So you can see that +1 and -2 and +2 and -3 are all soldered together, leaving -1 and +3 for my wires to get soldered to. And you can see here I have my red wire attached to my +3 and my black wire attached to my -1. I needed to have a heatsink on my LEDs so that it won't overheat. So the one day I was thinking, but I really didn't have any great ideas for it. So I took the LED to work one day and I asked my coworker, hey, I need to find a heatsink for this LED here. What would be good? So, he's kind of thinking about it, and we both walked over to a hardware bin, and then he suggested, well, how about a 1/2-inch nut? So I'm like, a 1/2-inch nut? I'm like, all right, well, so I took the LED, placed it right on top of it just to see how it sits, and it actually sit kind of nicely on here. So I thought, hey, great, this might actually be a great solution. So there are actually two types of 1/2-inch nuts that I've seen. One was a regular 1/2-inch nut, and the other one here is a crown 1/2-inch nut. These crown 1/2-inch nuts are actually good for if you thread something together and it requires a cotter pin so that these nuts will not come off. So I said, for the heck of it, I'm going to use these crown nuts. I had to find an adhesive that would be strong enough as well as handle the high temperatures of the LED. So the epoxy that I'm using here is JB Weld, and this one is made for steel. This has a cure time of around 4 to 6 hours. And here's the LED with the lens mounted onto the 1/2-inch nut. I was able to still use the epoxy that came up through the mounting holes to mount the lens on the LED fixture itself so everything could adhere as one piece. Once the epoxy has fully cured, I needed to put my LED fixture inside of a tube so that it can fit inside of 1-inch PVC pipes and 1-inch aluminum tubes. So I came across here a 1-inch polycarbonate tube, and it was just perfect for this application. I got my tube from McMaster.com, and it's part number 8585K14. It's 1-inch outer diameter with a 1/16 inch wall. And for this application, it is perfect because the LED fits nice and snug inside of the polycarbonate tube. Like so. So if you have an LED like this here, if it's short and stubby, I probably make this here about maybe 2 inches long so that it is stable on the inside of your pipe or tube here. But other than that though, if you want to make it short, at least make the polycarbonate tube about 1/16 of an inch or 1/8 inch above your lens here so that the blade will not hit your LED or the LED lens. If you're using a crown bolt, at least make the edge here of the polycarbonate tube even just before the crowns of your 1/2-inch nut begins. Use silicone or a silicone too, and depending on the lens you have on your LED, place some on the lens and on your nut, and then slide the whole LED fixture into the polycarbonate tube and allow the silicone to dry. You have your batteries, you have your LED, and you have your power switch. But what value of a resistor should you use to effectively operate your LED? Well, I'm going to show you a few simple math tricks in order to get the right value of resistance to work your LEDs. But the first thing you're going to want to look at is your batteries here. And the reason why, because this here is where it all starts. The battery that I'm using here for my Darth Maul double-bladed electronic saber here is an 11.1 volt 750 milliamp battery, and it's from batteryspace.com. But because that this here has a couple extra wires on here, I got this battery from hybridinelabs.com. And this battery here fits nicely inside of an 1.25 inch PVC pipe. So right now this battery is fully charged, and even though it does not measure 11.1 volts, we have to measure the voltage coming out of this battery. The voltage coming out of my 11.1 volt battery here is 12.5 volts. Just keep in mind that the higher the voltage that you have going to your LED can shorten its life or have a risk of actually burning out the LED. When I was studying electronics, I learned my formulas in the forms of these two triangles here because this was actually the easiest way that I learned how to find all my voltages, resistances, my currents, and my wattage here for all my circuits. So I'm going to show you how to use this here. It's very simple to use. Well, like for example here, we have our voltage here V. If you divide that into your resistance here R, you'll get your amps here in I. You take your voltage here, divide that into your amperage I here, you'll get your resistance here R. And if you multiply your resistance times your amperage, you will get your voltage. That seems pretty simple. Now also to find watts here, you could take the voltage here, multiply that by your amperage, and you get your watts here in P in power. So these formulas are very helpful, and again, it's very simple to use. So let's go ahead to a schematic on how to find your resistance. Here we have a simple series circuit here with our battery here, which is 12.5 volts. Now obviously you can see this is positive and negative here, our unknown resistor, our LED here, which is going to be this guy, which operates at 6.3 volts as indicated on LuxeonStar.com and has an operating current here of 0.7 amps or 700 milliamps. And also on top here we have our basic turn on, turn off switch here. Now keep in mind here that in a series circuit that current will always be constant, and our constant current here is always going to be 0.7 amps or 700 milliamps. So let's get started here on finding the value here of our resistor. So first thing we're going to do is find its voltage. Being that we have a battery here and the LED, we're going to do 12.5 volts, color it in a little bit more. Subtract that from 6.3 volts, and that's going to give the value of the voltage on this resistor here at 6.2 volts. Now the current here going through this resistor is going to be the same as going through the LED, which is going to be at 0.7 amps or 700 milliamps. Okay, so now we have our voltage and our current here going through the resistor, so now we can find the value of that resistor. So we're going to do 6.2 volts. We're going to divide that into 0.7 amps, and that's going to be 8.85 ohms. Now of course you're never going to get an 8.85 ohm here, so you could get like a 9 or 10 ohm resistor. You know, a little higher resistance is not going to hurt it at all. Okay, so now that we have the voltage on our resistor and our current, we can now find the power. So we're going to take our voltage on the resistor, which is 6.2 volts, and we're going to multiply that by 0.7 amps, and that's going to equal 4.34 watts. Now the power here usually indicates how much heat is going to get distributed here, but I would not stick with a 4 watt or 5 watt resistor here, because that the resistor is going to get fairly hot after a while. I would at least go up to a 6 or 7 watt resistor so that it will stay cool during operation. This is the resistor that I ordered from Newark.com. It is a 10 ohm 6 watt resistor here, and it should fairly hold well into my circuit for operating my LED. And here I just have a mock setup here with my LED, my battery, and my resistor here. So I'm going to just put my wires here to my power and see how the LED lights up. Oh, nice. So the LED is nice and bright here, and the resistor does do its job with keeping it, balancing out the voltage here and stuff. And my resistor here, well, starting to get a little warm here. Actually, maybe a little bit too warm. So that's why you don't want to stick with a close to value wattage here for this resistor, because if you do, it's going to get very hot. Maybe just by the touch here, maybe I should have gone up to 10 watt resistors so that it won't get as hot. So now you have the basic idea here on how to calculate the proper resistor for your LEDs. If you have any questions, I can try and help you out. So have fun calculating. Want to see what happens if your value of your resistor is too low? Please do not try this at home.